Hello and welcome to Richardson RFPD Test Chat. This is Peter Dietrich, Senior Technical Specialist for Richardson RFPD. Here today talking with Guy Moxey, Wolfspeed Senior Director of Marketing. Thank you for joining us, Guy.
Thank you. My pleasure, Peter.
We often receive questions from our customers related to the optimal switching frequency of silicon carbide devices. When comparing silicon carbide to silicon MOSFET and IGBTs, we know silicon carbide has faster switching capabilities, but why is it and how does one determine the optimal or maximum switching frequency for a given device?
Big question there, Peter. Big question. No one single answer. I would just say silicon carbide is magnificent across many different circuits, but bottom line is people use silicon carbide against, say, IGBT because, of course, those very fast switching rates and the lack of tail current, as you can see here. And then even within, whether it's a silicon carbide diode or within the body diode of the silicon carbide MOSFET, you can see we have this minuscule reverse recovery. I don't like it when people say no reverse recovery because it's impossible. But, we have 10,000 times less reverse recovery than what you would see in silicon. So combine these type of activities together and you can switch a lot faster for a lot less loss. Now, back to your question, what's the optimal? Why do you do it? We know why we can do it. Why do you do it? Generally speaking, if it's hard switched or soft switched, you increase the switching frequency, you can reduce the size of the magnetics with no compromise in loss. And this just shows you here a hard switched example. This is a PFC where we're up against a typical implementation of IGBT. IGBT is going to be switching 12 to 16 kilohertz probably. The magnetics, the loss is going to be a certain amount, and the magnetics are going to be this size. With silicon carbide, we can go 3 times that switching frequency, but bear in mind it's hard switched still, and this brings a dramatic reduction in those input filters, the cost, the size, and we even have less loss. So this is just the impact of hard switching. Soft switching, again, 3 times that switching frequency of silicon. Whether if you're 100 hertz for silicon, you could be 400 kilohertz, sorry, for silicon carbide. And again, that isolation capacitor and the input and the filters that boost inductors, the inductor and the magnetics come down considerably.
I understand. Thank you. Is there anything that can be done with a silicon carbide device designed to reduce switching losses even further?
Yeah, I mean, we just talked about, increasing switching frequency of a system, but just simple stuff. A 3-pin TO247 has the source signal connection along with the power connection. This has stray inductance. If you simply change to a 4-pin KELVIN source part from Wolfspeed, then you're effectively bypassing that source power inductance, and you can reduce the switching losses by about a third by just simply moving from a 3-pin to a 4-pin.
Thank you, Guy, for your insight on the optimal switching frequency for silicon carbide MOSFET.
Not a problem.
We appreciate your time today and thank you all for watching our Test Chat video. You can learn more about this and other topics on the Richardson RFPD GaN and SIG Tech Hub. Follow our Ask an Expert link to submit your questions related to design challenges you may have.